In this lesson, we are looking at rational exponents. The first thing we're going to do is we're going to investigate the meaning of a to the 1 over n power. And we are going to look at how we can write this in a radical form. So to start, a to 1 over n is basically going to represent and be the same as the n root of a. If you notice, my base goes inside my radical, and the n is therefore representing your index or your root. If I were to look at the relationship between these two things, we could look at the following as an example. If I had the square root of 5 times the square root of 5, I know that we get the square root of 25, and therefore I end up with 5 as my final answer. If I were to take 5 1/2 times 5 1/2, it's going to be the same. My base is going to stay the same, 5. 2 over 2, which is going to be the same as 5 to the first power, and therefore I can make the relationship that the square root of 5 is equal to 5 to the 1/2 power. If we were to look at several other examples, we could look at the following. I could see that if I had the cube root as 64, basically it would be the same as writing it as 64 to the 1/3 power. If I had, let's say, 84 and 1 over 4, it's going to be the same as the 4th root of 81, which I can still evaluate, which would actually give me 3 as my final answer. To look at several other examples, if I had x to the 1/2 power, the x is going to go inside my radical, and the 1/2, the 2 would represent my root, so it would be a square root, and that would be my final answer. If I had b to the 1/3 power, the b is going to go inside my radical, and the 3 is going to represent my root, so it's a cube root of b. And last and final example, p to the 1/10 power is going to be the same as writing the 10th root of p. Okay, now we're going to investigate, and we're going to add another component. We're going to add an extra exponent. So, if I had a, oops, I got my pen. A to the m over n power is basically going to be the same as writing a to the n root. However, the m now represents my exponent that I'm raising my base inside the radical to. So if we were to compare the following, if I had the square root of 5 to the 3rd power times the square root of 5 to the 3rd power, when I'm dealing with exponents, we're going to follow the same general rule. Even though I still have the square root sign, I'm going to ignore that for a second, and let's look. I still have my base of 5. 5 to the square root of 3 times 5 to the square root of 3. My base is still going to be the same, but now I can combine my exponents where it'll be 5 to the 6th power. If we continue on, I could actually write this. If I were to take the square root of 5 to the 6th power, it's going to give me the square root of 15,625, which therefore, oops, hold on, I have to go back. Which therefore would give me 125 as my final answer. We could also write this as the following. Taking the information from above, I could actually have my base of 5. The 3 being my exponent is going to go top of my fraction bar, so it will be 3 over 2 times 5, 3 over 2 root. So therefore, if I write this, my base will stay the same, and I will combine my two fractions of 3 over 2. Therefore, I get 5. And if you notice, I have a common denominator, so therefore my 3's add, and I get 6 over 2, which therefore can actually be written as 5 to the 3rd power. And if I raise 5 to the third power, I also get 125. So if you notice, it's written two different ways, but basically they represent the exact same thing. One is written in radical form, and one is written within an exponent form. Okay? All right. Let's look at several examples. Let's say I have x to the 5/3 power. Basically, this is going to be the same as my bottom number represents my root, so it's the cube root of x to the 5th power. If I had something like p to the power of 5/2, it's going to be the same as, if you notice, it's a square root. So I have a square root of p2, my exponent being 5, raised to the 5th power. When you break this down, it can actually be written in two different ways. If I had 8 to the power of 2/3, I could break it down and write the following. I could actually pull my exponent out, and we could do it as 8, where I'm still left with 1/3, but then raise the whole entire thing to a power of 2. I could therefore then write, looking at my fraction here, okay, and going back to the general rule we first did, basically it would be my cube root of 8, and then I could raise it to the power of 2. This would be the same as the following. I could continue to do the same thing of 8 to 2/3. I could then pull both parts out. I could actually go ahead and use my 2 where I square my base first, raise it to the power of 1/3, which would basically be the cube root of 8 squared. I prefer this one because it makes it easier in order to solve. Let's look at one more example. Now we have the reverse. We're going to add a negative component to this. And from what we learned in the last lesson, whenever we have a negative exponent, we can just take it and we can flip it. So if I have, for instance, if we have a to the negative m/n, it's basically going to be writing the same as a, or 1 over a to the m/n power. Okay? So if we were to take an example of 8 and negative 2/3, and if I were to write this, I'm simply going to flip it. I'm going to take it and do 1 over. Now I have 8 to 2/3. So therefore, if I'm looking at it, my root is cubed. So I have the cube root of 8 squared. And that would be my final answer. So if we were to compare and look at all of our notes, this summarizes everything that we just went through. If you notice this little portion here showing you and dealing with the positive exponent of m/n, where you are then raising it to an extra power, versus here showing you the negative, as to obviously you would have to flip it. So now you will begin your assigned problems. Good luck. Practice.